what I'm going to do is I'm going to talk about MATLAB, but I'm also going to share with you, my notes so that you can follow through, and then hopefully you will also have the video so you can practice yourself. And so the way I like to think of MATLAB is essentially like a calculator. That's the first part. Just to use your calculator to do computations, do complex calculations, you can use MATLAB to do the same. Um, so if you open MATLAB, which I did here, you see this layout, and you can actually change the layout. And this is what I would recommend. You always start with the default layout. Okay, so the default layout, you see the screen where you have the workspace, you have the command window, and then the folder which I'm in. Okay, so whatever you type in MATLAB appears in the workspace. What I mean by that, if you type a equals 1, so you do what you do in a calculator, which is 1 plus 1 or whatever you want, and you see that answer equals 2, and then it appears magically on the workspace. That's just telling you what is actually you wrote down and is stored in the memory. And this is useful because you could reuse it, which you probably can't in a calculator. You can reuse things, but you don't really see what is being saved, right? So MATLAB does that for you. Okay, so here's simple things. I'm going to just show you how MATLAB can be used to do simple things. Okay, so first of all, one sec. You can define variables. So A is a variable, okay, and you saw it appeared on the right. Then you can, B is another variable, and so you see it appear on the right side as a separate variable. If you want to save A plus B in a variable C, then you just do A plus B, obviously. And then here I'm going to just suppress the semicolon. Okay, and what you see is that when I suppress the semicolon, it actually prints C equals 3. It also saves C in the workspace. You could reuse C, just like I used A and B from memory. Okay, now MATLAB is an acronym for MATLAB Matrix Laboratory. So anything you write in MATLAB is actually a matrix. Okay, so if you want to find, if you really want to check if something is a matrix, then you want to see its size. Okay, there was one question: do we have to use MATLAB, or can we use Octave? You can use Octave. I have not really checked. Last I used Octave was probably 12 years back. So I've not checked the functionality of Octave. For the most part, I think the code you write in MATLAB is interchangeable with Octave. The only caveat I can see is that there are some toolboxes we'll be using, and these toolboxes are packaged inside MATLAB you buy the student version. So for example, the symbolic toolbox. And I'm not sure if there's an equivalent in Octave. So that's where you might have to come back to MATLAB, or Python has, I believe, a symbolic toolbox. You might use that, but I'm not going to provide code for Python. The code I'm going to provide is only for MATLAB. So you have to remember that when you use Octave. Okay. MATLAB, of course, can be used with Octave, but just if you use some special tools, then they may not be available in Octave. Okay, so that's the question. Okay, so I was saying that in MATLAB, everything is a matrix. So if you want to check if something is a matrix, the way you do it is, well, matrices are defined by rows and columns, right? And if you want to find the rows and columns of C, then you just say size of C. And what you notice is what pops up is 1, 1, 1, which means there's one row, one column. So anything you define in MATLAB is going to be a matrix. So let's go and define a vector 1, 2, 3. Okay. And then say size D. And what you see is it's 1, 3, means one row and 3 columns. If you want to define another vector, E, and instead of defining it to be 1, 2, 3, which is one row, 3 columns, I want to define it as 3 rows and 1 column. then all I do is I take E and I take the transpose or. So this is how I would write it. But why do the extra work? You already have defined D. So I can take D, take the transpose, and then I have E, which is now written as 1 column and 3 rows. So you can check the size. Comes out to be 3, 1. Okay. Another way of writing a a column matrix is 1 semicolon 2 semicolon 3, and that automatically puts it as 1 column 3 rows. Okay, so I have different ways of writing the same matrix. So the best part about MATLAB, which I really like, and this is sort of, if you look at Python, Python is a great tool, but what the way MATLAB beats Python, in my opinion, is that the documentation is really good. So Python is another tool which is open source, and it's also developed by people, developers. But MATLAB, there is somebody who is developing the code, but also developing the documentation. So I really like MATLAB for its documentation. So if I wanted to see more about the command size, which I used some time back, then I just say help size. And then you see this whole information about size. Size is size of an array, D equals size X. For a M by N matrix X, returns 2-element row vector. So it basically returns this D, which is M comma N, which you saw, 3, 1, 1, 3. Okay, so anytime you have any questions about size, MATLAB, and then you have information, the same information you'll find on the MathWorks website, but if you want to find other sources, then you can find it that way too. So this is really the power of programming, which is most of the information, most of the questions are actually been answered by people who have had this problem. So you can actually quickly search for whatever questions you have, and they'll hopefully pop up from the internet. Okay, now many times you're interested in generating random numbers. Okay, and there's a command called rand. If I type a equals rand 3, 3, it generates a 3 by 3 matrix consisting of random numbers. Now these random numbers are defined from 0 to 1. And the question is, how did I know it? Well, if you try help rand, it says uniformly distributed pseudo random numbers on the open interval 0, 1. So here's a command. So they've done some work for you, and you don't have to generate your own code to generate random numbers. Okay, now let me show you how to generate figures, and we'll call it a day. Okay. So let's say we want to plot the sine of t, where t is 0 to 2 pi. And so what I do is 2 equals linspace 0, 2 pi. Okay, so this is just saying that I want to generate points from 0 to 2 pi in some equispaced interval. In fact, I can specify how many points I want. If I want 500 points, I just say 500. So it's going to have 500 points from 0 to 2 pi. So equispaced points. So I type that. And then you can see that on the workspace, you have 500, which means there are 500 points generated inside T. Now let me write y equals sine T. Okay. And when I enter, you see that on the right side, you have another array of 1, 500. So that's basically taking sine of the first element, sine of the second T element, and so on. Okay, and then plotting is as simple as saying plot t, y. Now, can you see the figure? Sometimes people don't see the figure.
Yeah, I can see it.
Okay. Okay, great. Looks like people can see this. Okay, let me answer this question which came on the chat. For the project, do we have to build something, or it's focused on programming? Okay, so because we are online, I'm not expecting you to build anything. The projects are only programming and simulations. So there'll be some simulations in MATLAB, some simulations in Coppelia Sim, some simulations where you get a choice. You can choose between MATLAB and Coppelia Sim. Okay. Okay, so that's basic plotting. Sometimes, well, many times you want to put labels, and then there is a command called X label. You can say X, sorry, T, Y label, sin T. And you see that I actually wrote down 2 commands in a single line separated by the semicolon. That's perfectly fine. So now if you, the figure disappeared. If you want to see the figure, it's probably figure 1. That's the figure. Here's T, and there is sin T. Okay. So as I said, the best way to explore something is if you know there's a command, you could just type it and say help command name, and it'll actually show you what things are available. So for example, for plot, if you want to change this from a blue line to, let's say, a red line, then they actually give you the syntax here. See. So X comma Y is plotting the way I showed you. If you want to plot only points without having a T, you could do that too. If you want to plot with red, green, blue, then there is this extra argument S, where S is a character, and you can choose whatever you want. And they actually show you in help. And I think that's the best way to learn is there is this help example. Many times I program this way. I actually take the example, I paste it, I run it, I see what the output is, and then tweak it to suit my purpose. So for example, here's a example. I'm going to just close my figure. The command is close all, and then I'm going to just paste it. And then you see that this is the example which MATLAB gave you. And what needs to be done is if you want to play with it, let's say that you want to change the colors from, oh, it's already 10:51, I should stop. Let me just finish this and we'll be done. So let me change the color from green to blue. Okay, so you see that there is G, that is the green part. So I would paste it. Let me close this first, close all. And it changes to blue. Okay, they are blue. And so that's how I learn, which is basically take an example, paste it, modify it, understand it, and then adapt it to your code. So we are past 10:50. I'm going to stop. We'll meet again on Wednesday, okay, at same time, 10 o'clock. And in between, if you think that something was not right today, or you have suggestions for this, just email me, and I'll see what I can do my best. Okay, I'll see you on Wednesday. I'll stop for another 10 minutes. I'll be here online. If you have any questions, anything, I can talk with you or chat with you.